Given an unsorted array of non-negative integers, find a continuous subarray within that unsorted array that adds to a given number. Let's start with the function definition. Our inputs will be an array and the sum. We'll initialize several variables. One will be a lower bound or tail. Another will be an upper bound or head. Another will be the current sum as we iterate through the array. And we'll also need the minimum value in the array, which will be we'll iterate through the array incrementing I. We'll add current sum plus the ith element if I does not equal 0. Then we'll increment upper while current sum is greater than the given sum, which means if we've gotten to the point where adding the next number in the array pushes us over the sum that we desire to hit, and current sum. We'll continue the statement on the next line instead. So while current sum is greater than sum, and current sum minus the tail is greater than the minimum value of the array, which we found earlier, we're going to subtract the tail from current sum. and increment lower. Close off this while loop. If current sum is equivalent to sum, which means we found exactly what we want, then we'll break to the next line. Sum is found between indices lower and upper. And we'll break out of the for loop if we found it. We'll close the for loop. And if we've exited this for loop without current sum being equivalent to sum, that means that there is no such sum. And let's close off our function. Awesome. So let's analyze the space complexity and time complexity. The time complexity. So we have for loop, which iterates through all the elements. Within this for loop, we have operations of constant time, so our runtime is going to be O of n. Now for space complexity, we only initialize a few variables, nothing close to the amount of variables as there are numbers in the array, so our space complexity is going to be constant.